That rock here with some math. Let's solve trig equations where we have to use identities to help get to the solution. Okay. So far we've been looking at trig identities that are quite simple. This one that we're going to look at in this video, we need an identity to help us get to the quick, easy answer. So here's my example. I have 1 equals 2 cos squared x plus sine x. And I realized real quickly this is a quadratic form. If I subtracted the 1 over, I could set it equal to 0 and it'd be quadratic form, except the item that's being squared, the term that's being squared is a cos, and the linear term is a sine. And we know that if we're gonna factor something that's in quadratic form, we need the quadratic term to be the same variable as the linear variable. If this variable matches this variable, then I can factor. In this case, there's a greatest common factor. Or if there's a 1 over here, then I could factor like so. Okay. But the linear term has to match the quadratic term, and we don't have that. We have a linear term that's sine and a quadratic term that's cos. So what can we do? We can use a trig identity. So I'm going to first set it equal to 0, or maybe not. Let's just bust out our trig identity right away. We know from the Pythag variations that cos squared is the same thing as 1 minus sine squared. Now, we just made the problem a little bit more complicated because we added terms, but notice now our quadratic term is a sine and our linear term is a sine. So there's some hope that if we put this in nice quadratic form, it'll factor, or at least we can use quadratic formula. So I'm going to distribute the 2. And now I want to get it in quadratic form. I'd like this to be the leading term. You know, we like to have ax squared plus bx plus c equals 0. So this is going to be my ax in this case is sine squared. But I don't like this leading negative, so I'm going to move it over here. I'm going to add it to this side so it becomes positive. So I took this term and I moved it over there, and that makes it positive. I'm going to then therefore take this term and move it over as well, so it's going to become minus. We have this plus 1, and it equals 2. So now I'll subtract the 2, and I have 2 sine squared x minus sine x minus 1 is equal to 0. So nice quadratic form. And we hope it factors. And of course I set this up so it would. So we will factor 2 sine squared, which will be 2 sine x and a sine x. The only thing that gives us 1 is 1 and 1. Now we have to watch for our signs. We need a negative 1, so we want these to be opposite signs. But we want to make sure we get a negative in the middle. So that means I need a negative there and a plus there, because this negative will make the outer times the outer a negative 2 sine x. And then when I multiply these inner terms, I'll get sine x. And when I add that up, I get a negative sine x. So it factors nicely. Now what do you do once you have it factored? I'm listening. What is that? Oh, once you factor it and it's equal to 0, you can set the factors equal to 0. Because a number times a number that equals 0 means one of the numbers is 0. So we're going to take this number and set it equal to 0, and this one and set it equal to 0. So over here we get sine of x is equal to 1, and over here we're going to subtract 1 divided by 2, so we get sine of x is equal to negative 1/2. And now you just think unit circle. Let's see, where's sine 1? Well, that's going to happen in pi halves. And of course, every coterminal angle with pi halves, so 2 pi k, where k is an integer. Whereas sine equal to a negative half, well, that happens over in quadrant 3 and in quadrant 4. So in quadrant 3, that's 7 pi over 6. In quadrant 4, that's 11 pi over 6, or I could have called it negative pi over 6. And then of course, all the coterminal angles. And k is any integer. And that gives me the solution. Right there. So, ooh, can we see that? Did I write off the board? Sorry about that. So, we had a trigonometric equation that didn't look like we could put in quadratic form until we used a trigonometric identity that helped us put it in quadratic form, and then we could solve. Math made simple, Simpson math.